AI stuff works.
First, we teach them to see.
Then, they help us to see better. This quote by Fei Li aptly sums it up. As director of Stanford's Artificial Intelligence Lab and Vision Lab, Fei Li has worked to solve AI's trickiest problems, including image recognition, learning, and language processing.
Let's look at some of the popular applications and the AI working behind them.
How do smart speakers work?
Ever had fun talking to a smart speaker with a voice assistant, like Siri or Alexa?
Smart speakers use a machine learning recipe known as natural language processing, or NLP, to understand and respond to prompts in English or any other natural language. When you talk to a smart speaker, your voice gets recorded and sent to a far-off computer, where another AI algorithm, speech recognition, converts it to text.
Speech recognition algorithm, trained on large number of voice samples, breaks down your speech into smaller chunks and converts them into text.
This text is then analyzed by the algorithm to determine what response needs to be given to you. For instance, if you ask a Google Home device, "How is the weather outside?" the NLP algorithms will recognize the intent of your question, then use the internet to look up the current weather in your location. The speaker will then convert this information into AI-generated voice and respond to you with the current weather conditions.
To work really well, voice assistants use machine learning techniques to get better at understanding different accents, dialects, and speech patterns.
How does ChatGPT work?
ChatGPT can answer questions and talk to people.
It can answer logic questions, chat like a famous person, and even make jokes. But how does it do it? ChatGPT is trained using a lot of data on how to understand and respond to human language.
It learns from books, articles, and even the internet.
It uses this knowledge to predict the most likely next word or phrase in a context, based on the patterns learned.
This kind of a learning model is called large language model, LLM.
Imagine that you want to ask ChatGPT a question.
You type it in, and ChatGPT looks at all of the words you used.
It then tries to figure out what you are asking, based on what it has learned from all of its training data. For example, if you prompt ChatGPT, "What is your analysis, Sherlock Holmes?" ChatGPT can use its training data to find some of the distinctive language and syntax related to Sherlock Holmes, and respond saying, "My dear Watson." Why is AI art so amazing?
AI artwork is created using a type of AI model called Generative Adversarial Network, GAN.
GAN is a type of deep learning recipe used to generate new data. GAN has two parts, a generator and a discriminator.
The generator's job is to create fake pictures.
The discriminator's job is to catch if the pictures are real or fake. They keep going back and forth, with the generator getting better and better at making pictures that fool the discriminator into thinking they are real. Eventually, The generator gets so good that it can make pictures almost indistinguishable from real ones.
AI art has limitations.
AI often struggles at drawing fingers. Faces are more uniform and have distinct features like eyes, nose, and mouth.
Plus, there are many data sets available for AI to learn from, such as celebrity photos.
But unlike faces, fingers can be curled, stretched, or bent in various ways. This makes it hard for AI to replicate. Who knows, maybe one day AI will recognize fingerprints, and we'll all have to wear gloves to keep our secrets safe.
How does TV recommend movies? A recommender system suggests movies to users based on their previous movie watching history, ratings, and preferences.
The system uses machine learning to analyze large datasets of movie-related information, including genres, actors, directors, ratings, and user reviews. The algorithm uses collaborative filtering techniques to find similarities between users and their preferences. For instance, if you and your buddy have watched and rated the same movies, the algorithm will suggest any new movies that you rate high to your buddy. The algorithm also uses content-based filtering, which analyzes the content of the movies themselves, such as the genre, director, or actors, to make suggestions based on similarities between movies. How do robotic vacuum cleaners work? Robotic vacuum cleaners use machine learning and reinforcement learning algorithms to make a cleaning strategy and improve their cleaning performance over time. They are equipped with various sensors, such as infrared sensors, cliff sensors, and bumper sensors, which help it navigate around the house and avoid obstacles.
Before starting the cleaning process, the robot vacuum cleaner creates a map of the house using its sensors. It then uses this map to determine the best cleaning path and avoid areas that have already been cleaned.
They can receive feedback from their environment, such as how much dirt they have picked up, and adjust their behavior to maximize their cleaning efficiency.
When the battery level of the robot vacuum cleaner is low, it automatically returns to its charging dock.
How do autonomous drones fly?
Autonomous drones use reinforcement learning algorithm in combination with sensors and onboard computing power to fly by themselves. For instance, GPS sensor allows the drone to know its location and altitude. Other sensors measure stuff like speed and orientation of the drone. Such drones use autopilot systems to run their flight plans, a mix of hardware and software. Autopilot allows these drones to fly smoothly, avoid obstacles, and adjust directions without human prompts. The autopilot system analyzes sensor data to adjust the drone's speed, altitude, and direction. The RL algorithm aims to maximize the drone's performance. For example, the drone may be programmed to take off, fly to a certain location, and land. For each flight decision, RL algorithm receives feedback in the form of a reward and then adjusts future actions. Over time, the algorithm will continue to learn and improve its decision-making, enabling the drone to fly better. How does mobile camera detect faces? Camera face tracking uses computer vision algorithms to detect and track human faces in real time. The algorithm first identifies the location of the face in the camera's field of view, and then tracks the movement of the face as it moves within the camera's range. The algorithm uses machine learning models to recognize faces, including features such as the shape of the face, the position of the eyes, nose, and mouth, and other distinctive features such as facial hair or glasses. The algorithm also uses deep learning models to analyze facial expressions and predict emotions, such as happiness, sadness, or anger. How does face recognition work? When your mom clicks your photo, facial recognition algorithm analyzes the features of your face such as distance between eyes, shape of your nose, and curve of your lips. Next, these features are converted into a set of numbers and stored as a mathematical representation, called as your face print. When you unlock your phone using your face, the algorithm generates a fresh face print from the camera and compares this fresh face print with the face print stored in the phone. If the algorithm finds a match, it unlocks the phone. Facial recognition algorithms use deep learning to get better at recognizing faces over time. For facial recognition, deep learning algorithms are trained on large datasets of labeled face images to learn how to recognize faces and not to get fooled by imposters. Facial recognition algorithms have many practical applications beyond unlocking your phone. Law enforcement agencies use facial recognition technology to identify suspects in criminal investigations. Airports use it to verify the identities of passengers, and retailers use it to analyze customer behavior.
How do self-driving cars work? A self-driving car employs an arsenal of machine learning and deep learning algorithms to understand its driving environment, for it to be able to make lightning-fast decisions on how to navigate safely and smoothly. Some algorithms, working under the hood, making all this possible are path planning, sensor fusion, and object detection. They are trained on ginormous datasets on various driving scenarios, weather conditions, and road types. Firstly, the car's sensors and cameras capture information about its environment, such as its speed and the distance from other vehicles, pedestrians, and road signs. Secondly, a set of deep learning algorithms make sense of all this real-time information. Finally, another set of algorithms quickly make decisions whether to steer left or right, brake or accelerate. The various algorithms are tested in simulated and real environments, so as to ensure maximum safety for the passengers inside the car and the living beings outside the car. In summary, a lot goes under the hood to enable self-driving cars to run safely on the road. How does my phone complete my lines? Autocomplete is an AI method utilized in search engines and other applications to propose words or phrases based on the user's input. The method utilizes machine learning models to scrutinize voluminous datasets of anterior user queries and search histories. The method anticipates the subsequent word or phrase the user is prone to type based on diverse aspects, such as the recurrence of anterior queries encompassing the same word or phrase, the vogue of particular search terms, and the user's locality or language predilections. The method also employs natural language processing techniques to comprehend the import of the user's query and furnish more precise and pertinent suggestions. For instance, if a user types "weather" in the search bar, the method might propose "weather forecast" or "weather in New York." When AI fails, there are several technical limitations that AI algorithms currently face.
Some of these include interpretability.
Many AI algorithms are black boxes, meaning it is difficult to understand how they arrive at their conclusions. This lack of transparency can be a problem in certain applications where it is important to be able to explain how the algorithm arrived at a particular decision.
Lack of common sense.
AI algorithms do not have common sense or general awareness that humans possess. This can limit their ability to understand the world and make them incredibly stupid.
Overfitting.
Overfitting occurs when an AI algorithm is trained on a limited dataset and becomes too specialized in predicting based on that dataset, but shows very poor predictive performance when presented with new data.
Scalability.
As the amount of data used by AI algorithms increases, the algorithms can become computationally expensive and may require significant computing resources to operate effectively. Remember, overall, while AI algorithms have made significant progress in recent years, there are still many technical limitations that must be addressed in order for AI to reach its full potential.
To conclude, let's hear what Stephen Hawking said about AI. Artificial intelligence is a tool that can be used for good or for evil.
If we develop it for the common good, it will bring us tremendous benefits. If we develop it for our own selfish purposes, it will bring us unimaginable harm. Thank you for watching, listening. Don't forget to like and subscribe using the bell icon.